you know, no slaves in Africa, children getting buried alive, trying to, like, no more of that insanity. And it's from my perspective, that's a fulfillment of my covenant. Just like yours and your, but you can't fulfill your covenant. But I'm fulfilling mine. But this now gives you the ability to fulfill yours. And it's going to happen.
So you're not interested in, you know, a company comes along and say, we'll give you $2 billion for the technology, they take it, they bury it. Because they've done that.
No.
Like, you're not interested in that.
No, we're rewriting the laws of physics.
You want to see this.
You can't, we're rewriting the laws of physics.
He's not in it for the cheddar, basically.
We're rewriting the laws of physics. Once the laws of physics are rewritten, there's no going back. There's no going back.
Have you looked at what Michael Faraday is also well known for?
Yeah, the transformer. Michael Faraday invented the first electric motor in 1822, the generator in 1834.
He also discovered the electromagnetic spectrum of light.
Yeah.
He found infrared by mistake,
Yeah.
by pure luck. He wanted to measure visible light when it was split by a prism. The prism will split depending on the wavelength, from violet to red. So he put thermometers on the light that was split by the prism to measure if there was a difference. There was a thermometer at the very end, by mistake, over the red, and temperature there was higher than everywhere else. That's how he discovered infrared.
Mm-hmm.
Now, he also, on the other side, he discovered ultraviolet. He discovered microwaves. He discovered radio waves.
Yeah.
All going against
All by mistake.
But the commonality there, he was measuring the presence of photons.
He was measuring wavelengths.
Yeah, but the electromagnetic spectrum is made of photons.
Light photons.
Photons. What we're talking about here, photons.
Okay.
So
the visible part of the electromagnetic spectrum of light, visible, is a tiny portion of what the full spectrum is. So I'm wondering, if he discovered things by accident, you're probably onto something.
no, this was discovered by accident.
What?
Yes, this was discovered by accident. The first, I designed a generator coil that was meant to be neutral. So the generator coil is like this, and when current is induced in it, it creates a magnetic field. The magnetic field goes from the coil, it enters the air gap, and it impedes the rotation of the rotating magnetic field. So what I did was I designed a coil that was circular, a toroid, and I put two coils on it, and I excited both of the coils by one magnetic field, and I had a core so that the created electromagnetic field wouldn't enter the air gap and wouldn't impede the rotation of the rotor. It was meant to be neutral, which was the idea that I presented to my professor when I was 18, sitting in my motors and generators class, when I said, if we can divert the magnetic field out of the air gap, then we can make a generator that's more efficient. And his answer was, well, first you're going to have to violate Newton's third law, first law, Newton's third law, the law of conservation of energy, and yada, yada, yada. And you can't do it, so don't even try. So when I built my coil in 2005, I was, in 2007, I was testing my toroid coil against a conventional coil. But I used up all my thick gauge wire to make the conventional coil. And all I had left was thin, very thin gauge wire. So I made a coil with the wire that I had, and it was a high impedance coil. So that when I tested my coil that was supposed to be neutral against the high impedance coil, which is what's in here, this was neutral, but this one, when I placed it on load, the system started to accelerate. And it accelerated so much that it started to self-destruct itself. And so I spent the next week trying to eliminate the acceleration problem. What you're seeing here, positive work. When I couldn't eliminate it, and I mean, I was a motor technician at the CIP in Gatineau, I took everything apart, put it back together, ran the test again, and same thing. That's when we went to MIT and we said, where's the acceleration coming from? What is this? This is not supposed to happen. It's supposed to slow down. And it was a problem for me because I wanted it to slow down. I didn't want it to speed up. And Dr. Zan at MIT, who's now deceased, said, don't ask me. It's never been seen before in the history of electrodynamics. And it was a fluke. It was, if I would have had, and it was, I built that coil on a Sunday, and if Radio Shack would have been open, or if I didn't already buy up all their magnet wire, which I did in every store close by, if I didn't buy up all the magnet wire, they used to hide it when I would fucking they used to sell it in red, green, and gold. And the gold was the thin, and then the red, and I think the green was the middle, and the red was the thickest. Well, I had a box full of the gold stuff that was useless because it was too thin. But that's all I had. So I made a coil and boom, that's the discovery. Complete fluke. There you are.
I believe you.
Like, absolutely.
Albert Einstein said nothing can move faster than light. Light travels at 186,000
Except for
miles
Bogdan
per
when his
second.
wife calls him.
Now,
When Bogdan's at the tennis court and his wife calls, he's faster than the speed of light. I'm out of here, guys.
but now, with the James Webb Space Telescope, which operates in infrared, they're measuring the rate that the universe is expanding. And the further away the galaxies are, the faster they're expanding. They're not moving faster than light, but the space is expanding faster than light.
So that's a discovery.
And that's just a very recent discovery.
Again, by fluke?
Again, by fluke. Yes.
Every great recipe, every chef will tell you, every great recipe is a fluke. Most inventions are flukes.
Yeah.
I mean, post-it notes, the glue, that's a fluke.
And astronomers are the first to say, we expect to be surprised.
Yeah,
We expect the unexpected.
yeah. Yeah, because what we call physics is a